ignition and liftoff of Transporter-4.
Pitching downrange.
You can see the two fairing halves have separated from the vehicle, exposing the 40 spacecraft to the vacuum of space.
MP-42, separation confirmed.
Now it's time to turn our attention to the second satellite that's being launched today after the Falcon 9 has been through its coasting phase, which is the MP-42 rideshare mission. As you know, it hasn't deployed yet. Hopefully in roughly 30 minutes, we'll see a successful deployment of the MP-42. But in the meantime, let's talk to Omar Qaise. Omar Qaise is the CEO of OQ Technologies, and they have one of their 5G cell tower in space on board the MP-42 today. This is part of OQ Technologies' growing 5G, IoT and machine-to-machine communication constellation. So Omar, it's great to have you with us. Many thanks for joining us.
Hi, thank you very much, Michael. It's a pleasure to meet you, I'm very happy to be here again.
Great. Let's kick off by mentioning that the MP-42 is not your first mission with nano avionics. Actually, in 2021, you launched the Tiger-2 nano satellite, which has been performing operations for some time now. So it'd be great if we could get a quick overview of what technologies and services you're developing at OQ Technologies and how Tiger-2 has been performing and supporting that.
So OQ Technology is the world's first company and only company providing 5G Internet of Things and machine communication by deploying a low Earth orbit nanosatellite network. And the idea here is really we want to extend the coverage of cellular communication everywhere in the world so that users could roam freely between terrestrial mobile networks and our satellite network. Back in 2019, we tested for the first time in the world narrowband IoT technology with a low Earth orbit satellite. That was our Tiger-1 mission. And as you mentioned, last year we launched our first commercial mission, the Tiger-2, together with Nano Avionics and space flight on a Falcon 9 rocket. And this has been performing very well. In fact, we from day one when we switched on the satellite, we had signal acquisition. The payload was performing very well, both in uplink and downlink. And we were able to do a lot of service pilot tests with our customers. Some of these very large companies, some are Fortune 10 companies, and they were impressed with the performance of the service. So we were actually deploying our user terminals that allow the users to collect data from sensors and send the data to the Tiger-2, and then it goes to the cloud where they could access their data. And it was impressive. We even had indoor coverage. Even when you cover the terminal with the sand or put it inside a car and drive around, we were still able to detect the signal and relay the data. So this is very revolutionary for us. And we're still actually continuing our pilot program. So anyone who would like to sign up for our demo kits, they can contact us and we'll provide them that to do testing of the service with our Tiger-2 satellite.
Brilliant. Really impressive progress and great to see how successful that is in terms of what you can provide to those huge clients that you're mentioning. Let's talk about the future. So on board today, the MP-42, you have your new payload, and when we hopefully see that deploy in a few minutes' time, that will mean another operational payload in orbit. Talk us through what your plans and vision are for the future and how the MP-42 payload can contribute to that.
So the MP-42 will host our third mission, which is the Tiger-3, and it's actually the same payload as Tiger-2, but the difference this time we're hosted on a bigger platform, so a microsatellite. And this is very interesting for us because we are trying to look into the possibilities of using more power of the satellite platform to deliver service, higher capacity, see how that will be in future. For example, if we want to add more beams or more narrowband IoT carriers to address larger number of users and higher capacity, we're going to be using microsatellites. So it's a very unique experience for us. We're going to learn a lot from it. But at the same time, we're adding this to our constellation. So the Tiger-3 will join its Tiger-2 companion. And that allows us to offer more passes per day for the users. So today, if they have 2 passes per day in one area, they're going to have 4 passes, and we can do more applications with that. For example, smart metering, or uploading larger amounts of files, also testing firmware updates and on the downlink. So that's the benefit of using the MP42 Tiger-3 mission together with our Tiger-2.
Fantastic. To finish up then, a bit of a broader question, because a lot of your technologies are aimed at democratizing access to 5G, democratizing the use of satellite communications through, for example, cheaper and more affordable components. Could you talk us through then, satellite communications have typically been seen as rather expensive compared to ground networks, and that's maybe one of the reasons they've been synonymous more with remote communications, where higher costs could be justified. Do you think this still holds true for 5G IoT, or might we be seeing, as we see a reduction in the service costs, wider adoption around the world of this technology?
Indeed, 5G will actually revolutionize the satellite telecommunication world, because it's bringing a massive scale. Because of the scalability. The technology is scalable, is made for millions of users. You have already an existing ecosystem with multiple chip vendors, multiple operators, multiple device manufacturers, and that actually will reduce the cost dramatically, both for the hardware and also for the service. And it will be different from what has been offered before in the satellite telecommunication world. From day one, we looked at 5G technology as the key for the future for machine communication and IoT. As you know, there are a lot of proprietary technologies out there like Sigfox, LoRa, and all. We see them disappear slowly, while the global standard of cellular is what is staying and what will continue for the future. And that's why we decided to use that and bring it to the satellite world. To give you an example, what we are working towards in the future also is to provide the world's first hybrid terrestrial satellite narrowband IoT and LTE-M chip, which can allow a lot of users. We are collaborating with a US company, Alif Semiconductors, in order to deploy our IP on that chip, which is already existing for narrowband IoT applications. And that will open the door for a very massive amount of users who can take benefit of this new technology for a very low cost chip that costs the same as a cellular chip, but can do at the same time both terrestrial and satellite communication. Also, we're working on very advanced payloads for future to host more advanced 5G IoT stack for the base station on the future upcoming satellites.
Fantastic. Omar, huge potential with what you're developing, and brilliant to see that big picture to finish off our conversation here. Thank you so much for joining us and sharing your insights. And do stay with us so we can get your reaction when we see, hopefully, a successful deployment of the MP42 satellite.
Thank you very much, Michael.